Hey, welcome to Chemistry with Sir Santi. For this video, we will be talking about scientific notations. Very large numbers and very small numbers are conveniently expressed as powers of 10 in the form of scientific notation or exponential number. Scientific notation is a process of expressing a number as a product of an integer, whether it's a positive or a negative number, between 1 and 10 multiplied by an appropriate exponent or power of 10. Scientific notation is oftenly or is systematically expressed as integer times 10 raised to the power of n, where n is any positive or negative exponent. A positive exponent tells how many times the integer must be multiplied by 10 to convert it into decimal notation. Example, 1.94 times 10 raised to the power of 3, which is technically translated by multiplying 1.94 times 10 3 times. So 1.94 times 10 raised to the power of 3 is basically 1940. We can also apply a different way by moving the decimal point. When the exponent is positive, just move the decimal point to the right. And in this case, we need to move it 3 times. 1, 2, 3. And add 0 on the blank spaces. So still we got the same answer, 1940. A negative exponent tells how many times a number must be divided by 10 to convert it into decimal notation. Like for an example, 1.94 times 10 raised to the power of negative 2 can be technically translated as 1.94 divided by 10 2 times. So 1.94 times 10 raised to the power of negative 2 is equals to 0.0194. We can do a different way by moving the decimal point to a specific direction. When the exponent is negative, we'll just have to move the decimal point to the left. And for this case, we have to move it 2 times. We still got the same answer, and that's 0.0194. In multiplication, the exponents of common bases are added to get the exponent of the product. For an example, 10 raised to the power of 3 times 10 raised to the power of 2, we just need to simply add the exponents because they have the same bases. So the answer is 10 raised to the power of 5. In division, exponents of common bases are subtracted to get the exponent of the quotient. For an example, 10 raised to the power of 5 divided by 10 raised to the power of 2, we just need to simply subtract the exponent. So the answer for this is 10 raised to the power of 3. In an exponential expression raised to a power, multiply the two exponents. For an example, 10 raised to the power of 4 times to the power of 3. So we just simply multiply the exponents. So the answer is 10 raised to the power of 12. In an exponential expression raised to a negative power, multiply the two exponents. The exponent will have a negative sign. For example, 10 raised to the power of negative 2 times to the power of positive 2. So simply multiply the exponents, and the exponent should be negative. So the answer is 10 raised to the power of negative 4. If a scientific notation is raised to a power, multiply the integer based on the exponent. For an example, 2 times 10 raised to the power of 2 times to the power of 4. So 2 raised to the power of 4, that's 16. Copy times 10, and multiply both exponents. So 2 times 4 equals 8. 16 times 10 raised to the power of 8. That's it. Let's connect through my social media accounts in YouTube, Facebook, and Instagram. Thanks.